All right. Section 3.4 in geometry is very similar to section 3.2. Except what we're doing now is we're flipping the theorems around. A lot of you would think that maybe if the theorem works kind of in one direction of reading it, that it would work in the opposite direction of reading it. And it doesn't necessarily have to work that way. Okay. For example, I could tell you if you know you have a square, then you know there are right angles, correct? If you know you have right angles, are you guaranteed to have a square? Do you see how I reversed those? Is there a guarantee that it's a square? No. It could be a rectangle, correct? So there's no guarantee that they work in both directions. But the ones that we have here actually do. So for example, before, like in this green here, it said if two parallel lines are cut by a transversal, that's how we started them, correct? Then each pair of alternate interior angles is congruent. We learned that. We know that to be true. Now the theorem would read, if two lines in a plane are cut by a transversal so that a pair of alternate interior angles is congruent, then the lines are parallel. Okay? So do you see how it is slightly different? And this one does work in both directions. Okay? It is true both ways. So a lot of the work we're going to be doing today is work you've already done. So some of it should not seem all that different, but we are also going to attach to it either the postulate or theorem that worked with it, and I'll try and give you, there's lots of words that I'm throwing in here like postulate and theorem. I'll hopefully make those very clear. Okay? So this very first one, this is before we knew the lines were parallel, correct? So this is like an example from 3-2, perhaps. And so if I knew angle 6 was 3x plus 5, and we knew that angle 3 was 4x plus 2, we could look at those, because again, I know those two lines are parallel. Well, what type of angles are there? What's the angle pair name for those two, for 6 and 3? Alternate interior, very good. And so what do we know about alternate interior was the one I gave you on the other one, right? Is that they must be, if the lines are parallel, they have to be equal, or what's the word we use? Congruent, right? So we know that those two are equal, or in other words, congruent, so we can set them equal. Remember, it's the consecutive interior that add to 180 or are supplementary. So that for consecutive interior would be 6 and 4 and 5 and 3, and those aren't the ones that we're talking about now. So I know this to be true, so now algebraically we would have to solve. And we know we have an x on both sides. Normally I like to move the smaller of the two, so let's get all the x's over here. Again, not the only way you could do this problem, but it is a sufficient way. So 3x plus 5 minus 3x, well, those just cancel. So in other words, I'm left with 5 equals not 4x. Because if I look at the right side, it'd be 4x plus 2 minus 3x. Well, 4x minus 3x is just 1x plus 2, subtract 2 to get it over there. This is an equal sign, sorry. So 3 equals x. Do you believe that to be true without a doubt? Yeah, probably best to do what? Probably best to check. So let's substitute 3 back in there. So 3 times 3 is 9, plus 5 is 14. If this is accurate, that other angle better also say 14. So let's put 3 right in there. 4 times 3 is 12, plus 2 is 14. Now, do those look like 14-degree angles? No. But is there any guarantee that I have to draw these to scale? No. You have to follow the math and the logic, not because it looks like it. Okay? Does that make sense that they end up the same? It does. Okay? So they also want the measure of angle 6, so we would say 14 degrees over there. So we know x ended up being 3, and the measure of angle 6 ended up being 14 degrees. Okay? So that's kind of what we did before. Nothing new there, right? So now let's take a look this way. Now we're going to determine the x. Oop, one thing I forgot. In your assignment, it's going to ask you to state a postulate or theorem that made this possible. And I just need you to be very general about it. I'm not going to ask you, is it theorem 3-2? Okay, the reason I don't do that is because if you had a different textbook in some other school, it might be theorem 4-5. It depends on how the books number them, right? So I'd rather you know the names of them because then they're the same everywhere. They have the same name. Okay? Why did we basically know this was true? Because we know that, so this could be the name of the postulate, that alternate interior angles are congruent. I'll allow you to just say that as your And really that would be a theorem, because a theorem is something that has to be proven. And that actually had to have been proven at some point. A postulate or an axiom are two words that go back and forth. That's something that we kind of just agreed to be true before we started. Okay? But this one had to be proven. Okay? So you can just say that's the postulate that got me that answer, because you will be asked that on your homework. So now let's go to this one. Now we are going to determine the x value that will guarantee the line's parallel. So I don't know they're parallel. So I want to find whatever x value that I can put in here that'll make it happen. So once again, if we look at these, are these still alternate interior angles? They are, because is this still a transversal? Because it is still hitting two or more lines, right? Now, do we know for a fact they're parallel? No. Because if I pick some x values, maybe they won't be parallel. But there is a particular x value that will make it happen. And I know it's only one because they are linear, right? There's no exponents on it. So what do I know about this angle here and that angle there? If the lines are parallel, those better be the same because they're alternate interior again, correct? So let's do that. So 3x plus 7 equals 5x plus 3. And why don't you take a second and do that algebra on your own so that I make sure that you can all do it instead of just following me. I'll come around and see how you're doing. Those that may be listening to the recording actually do this and don't just wait for the answers to pop up. Well, let's find out how you did. So with this one here, probably you don't have to do it this way, but again, I would probably move this one first. So 3x plus 7 minus 3x is really what we have on the left side. Those do actually cancel out. So I am left with just 7. On the right side, we have 5x plus 3 minus 3x. And let's see, 5x plus 3 minus 3x, well, that ends up being just 2x plus 3, I believe. Now again, I could, if I wanted to, divide everything by 2 right now, but let's not do that. We'll subtract 3. So on the right side, I have 2x plus 3 minus 3. Well, those cancel, so I got 2x equals 7 minus 3 is 4. And it's good. This looks like it's going to come to an answer that I saw on a lot of your pages as I went around. Because 2 divided by 2, that's just 1. And 4 divided by 2, that's 2. So apparently x equals 2 in this problem. That will make it work out. Now again, we should check. Make sure. Let's substitute 2 back in. 3 times 2 is 6, plus 7 is 13. Again, does not look like a 13-degree angle. That doesn't matter. Put 2 in here. 5 times 2 is 10, plus 3 is actually 13 degrees. So R, L, and M guaranteed to be parallel at this time. They must be. They have to be. And now what would the postulate be? It'd be the same as the last one, right? And we can start abbreviating then. Alternate interior angles congruent. That's how I work right there. Alternate interior angles are congruent. Okay. And I'm fine with you just listing that. Because like I said, if you went somewhere else, it might have a different number, and so that's why we don't do it that way. Okay. Everybody good? All right, let's do it. Determine the value of x and the measure of angle VST that will make L parallel to P. So we know we have a transversal. I don't have a name on it, but it is hitting L and P. So we know that much. Well, what type of angles are we got? 3x minus 4 and 12x. What operations on that? Minus? Mine apparently is missing the minus down here. There you go. What kind of angles are we looking at? Yes? Nope. Very good. Not quite corresponding, but they're close. They are consecutive interior, right? Because they're on the same side. And so now we have to learn, well, if I want those lines to be parallel, what do we need to know about those two angles? Must they be congruent? No, I see a lot of people shaking their heads. They must be, yes. Equal 180, otherwise known as supplementary. So let's add them together. So we've got a 3x and a 12x right there. Do I need to move them from one side to the other or anything like that? No. Just add them together. Right? It's 3x plus 12. That's what, 15x? And then I've got this negative 4 and that negative 11, so it's negative 15 when put together. Any questions on that so far? Add 15 to both sides then. So 15x minus 11, or minus 15 plus 15, that cancels, equals 195 apparently. All right, we got to get this out of here, so divide by 15, because I want to know what 1x is, and 15 over 15 is 1. And does 195 divide evenly by 15? What is that? 13? Is that what it is? So supposedly x equals 13, but I would like to check. We were told that those two better add together to be 180. So if we put 13 right in there, it'd be 3 times 13. Does anybody happen to know that one off the top of their head? Is 39, and then minus 4 is 35, so that angle's 35. So how about 12 times 13? That's a little bit harder. Does anybody know that one? Off the top of 156, very good. 156 minus 11 is 145. Did that work out the way it was supposed to? Yes. And this time I even made the angle somewhat believable, right? It even kind of looked like it. Now, what's the hard part about this question? What is hard about this one? Yeah, what's hard about this one? Yeah. Yeah, it says to find VST, and there isn't even anything in there. Well, that's weird. Well, that's just one of the ways I can combat you working ahead, because I don't believe I have VST in yours either, do I? No? So we'll add VST in there. I don't know. I think V right here would be good. S right there. And T right there. So now angle VST is right there. Well, why would I put it there? That isn't even one of the angles we were looking for. What's going on? Yes? Okay, what I was told is that 35, the person was pointing right here, and TSV should be the same, because they're across from each other. Do you always agree with that? What's the vocabulary term I'm looking for here? What type of angles are they? Vertical angles, very good. And we know by default that vertical angles will be congruent. So can we now answer VST? Yes, it is 35 degrees. And angle, what was x? Or just x was 13, right? So there we go. And what would be the postulate this time? Well, I'm just saying for this one. Yeah, consecutive interior angles are supplementary. Okay. So far we've done 2 of them, right? We've done that alternate interior angles are congruent. We've done consecutive interior angles are supplementary. How many more have we really learned? 2 more, right? What were those? Let's maybe write those down on the next one. So does everybody have consecutive interior, and we've got alternate interior? Well, what were some of the other ones that we learned? Corresponding, okay, so corresponding, just in case you need to use these, right? Corresponding, I don't know why there's an S on there. Corresponding angles are, what would we put? Corresponding angles. If the lines are parallel, corresponding angles will be congruent. Very good. So that's one of them. So that's 3. You told me there was 2 more, so that's one of them. What's the last one? Alternate exterior. Very good. So your other postulate you can use is alternate, well, actually it's a theorem. Alternate exterior angles are congruent. Very good. And you can abbreviate them like that. I'm more concerned that you know the theorem itself. Okay, and keep in mind that this may become on a test sometime, the difference between a theorem and a postulate or axiom. Those are kind of the same. Those 2 words are interchangeable, postulate and axiom. Those are things that we just agreed to be true. Okay, for example, that 2 points when connected make a line. That's something we all agree upon, correct? Okay. And then theorems are things that if we took all those axioms and put them kind of together and used them, we prove that these things are true. Those are theorems. Okay. Questions on today's notes, on any of what we've covered? No? All right.